Hello everyone, I am R. Lathikapooja 17E050. Today I am going to describe about multi-terminal HVDC system. Contents of MTDC system. Today we are going to see are abstract and introduction, types of MTDC system, applications, typical problems, advantages and disadvantages, future aspects and conclusion. Abstract. The need for active network connection at both ends, its inability to reverse the direction of current flow, and its susceptibility to commutation failures have been the downsides of classical HVDC. The shown one is classical HVDC system. This picture, this is converter. Left side image is a converter station. Converter is there, AC filters, AC bus, transmission line, smoothing reactor, VSC, HVDC. A recent arrival in the arena of high voltage technology has eliminated all the mentioned drawbacks of classical HVDC. It has attracted attention for developing multi-terminal HVDC system. Introduction of multi-terminal HVDC system. um, Definition: a multi-terminal DC system, MTDC system, has more than two converter stations, some of them operating as rectifiers and other as inverters. The simplest way of building a MTDC system from an existing two-terminal system is to introduce tappings. Parallel operation of converters and bipoles can also be viewed as multi-terminal operations. MTDC is a DC equivalent of AC grid, which will have DC transmission network connecting more than two AC or DC converter stations. Multi-terminal HVDC system. The task of extending two-terminal systems to multi-terminal system is not trivial. The complexities of control and protection increases. The use of HVDC breakers is generally required in the MTDC systems. With recent advances in the emerging technology of VSC HVDC transmission, the application of MTDC system is becoming more attractive than before. Types of MTDC system. There are two types of MTDC system. They are series and parallel. Uh, the series and parallel image is shown here. Then further, the parallel MTDC system is subdivided into two categories, that is radial and mesh. Comparison: high speed reversal of power is possible in series without mechanical switching. The valve voltage rating in a series system is related to the power rating, while the current rating in the parallel connector system is related to power. Insulation coordination is a problem in series systems as the voltage along the line varies. There are increased losses in the line and valves in series system in comparison to parallel system. Potential applications of this multi-terminal HVDC system: bulk power transmission from several remote generating stations to several load centers. Asynchronous interconnection between adjacent power system. A MTDC system for interconnection is more flexible and economical than employing several two-terminal DC links, reinforcing of an AC network which is heavily loaded. The typical problems in multi-terminal HVDC system are some of that can be considered for study, which is operation of small inverter taps connected to weak AC systems, integration of existing HVDC converter stations and empty DC systems without major modification and control. Evaluation of communication, reactive power, and filtering requirements. Power and reactive power modulation strategies in empty DC system. These are major typical problems in multi-terminal HVDC system. Advantages. Advantages of multi-terminal HVDC systems are the power reversal in a converter is achieved by current reversal, which is easily arranged by control action without using mechanical switches. There is no problem of commutation failures. It can even supply passive loads. The use of PWM, that is pulse width modulation, eliminates low frequency harmonics and simple AC filters can be supplied. There is no need for reactive power compensation of VSC. Actually, a VSC can supply reactive power and can help in the control of the AC voltage. High speed reversal of power is possible. Overall efficiency of the system increases. Economical and environmental advantages are also there. This is more economical and environmental to the surroundings. Disadvantages. Large smoothing reactor may be required to help in the recovery of a small inverter from AC faults. The speed of recovery of the entire MDDC system depends upon the recovery of a small tap. It is necessary to consider the effect of mode shifts and develop additional protection sequences, particularly for faults in DC line. Multi-terminal systems are difficult to realize using line computed converters. Future aspects in multi-terminal systems are as follows. Power distribution on vehicles. It will be a backbone of microgrid. It will also used in offshore wind integration, which is a major aspect. Supergrid, that is mass integration and transmission of renewable energy. AC islanding, which is splitting AC system into smaller segments. Conclusion. Although the concept of multi-terminal HVDC systems has been discussed for a long time, the implementation has been very limited. The complexities in control and protection have deterred many utilities from experimenting with MDDC system operations. Introduction of MDDC system requires extensive R&D activities to solve the problems associated with MDDC system. It is anticipated that emerging technology of VSC HVDC transmission can help solve many of the problems and encourage utilities to introduce MTDC systems. This is the conclusion. In today's topic, we have seen the abstract introduction. This is it has more than 2 converter stations. Some of them operating as rectifiers and others as inverters. Types, series and parallel, in which parallel is subdivided into radial and mesh. Comparison we have seen. Potential applications. Bulk power transmission from several remote generating stations to several load centers. The various problems in advantages, which is economical and environmental. Efficiency of the system increases. It can supply passive loads. There is no commutation failures. Disadvantages are the speed of recovery depends upon the recovery of small tap, or difficult to It is difficult to realize using line commutated converters. Large smoothing reactor may be required. Help in the recovery of small inverter. Large smoothing reactor requires to help in small recovery of small inverter. Future aspects: it is a backbone of microgrid, offshore wind integration, power distribution on vehicles. Conclusion: thank you.